Alright, so we have number of people who like ice cream is 400. Sample size is 900. Alrighty, let's see if we can do a 95% confidence interval. You will, and you know exactly how to do this. Because 95% stick out of your mind up. Yes. From something that we may have done in the past. Okay, because all the things we're going to be doing in the future all connect to what we have done previously. Does 95 stick out to you? What are your numbers? 2 standard deviations away from the mean. I want you to sketch a little picture. Okay. We want, the answer was no, since when is this a negotiation? Okay, we want the 95% in the middle. Okay, when we finish this, we'll be able to say that we're 95% confident that the mean is located within this space. It's a pretty big space, and we should be pretty confident as well, because it is a decent size. Now, you said you remembered 95% from something before? From what? That rule, you got it. And how many standard deviations? 2, which means here's your mean, right? And then here was 1 standard deviation, and here would be your other standard deviation away. It was technically like 4 standard deviations altogether that made up that 95%, right? 2 from below, 2 from above. Can you calculate how much is in there? Yes. Okay? Can we calculate how much our probability is between here? So, when you think about it, what does that mean? If 400 people out of 900 like ice cream, same thing as what we did today. What's 400 divided by 900? 4 over 9, which is? You don't know the math? The fun? No, 0.44444, because 1 out of 9 is 1 not per 0.11111. 2 out of 9 is 0.22222. 3 out of 9 is 0.22222. Okay, so I'm going to put 0.44 as my mean inside here. Okay, because from before we know that the mean of our probability proportion is just the probability. So there we're just putting 400 out of 900. Okay? Anticipation, okay? How much do you think is 95%? You said 2 whole standard deviations away here. Okay? How much is a standard deviation so that I know how far over I'm going? We need to find okay. So, got the formula sheet? Sure? Not the NP one, just the P times 1 minus P over N. So let's take a minute and calculate the standard deviation. So we've got 0.44. What's 1 minus 0.44? 0.56. It's always like this, like the opposite next to it. I don't know if you ever noticed it. It's always the opposite. How many people did we survey, or in our sample? 900. Take a minute to do the math. Take out that beautiful Inspire calculator you got provided. Okay, I did all my math, so I know what P. You get a pat on the back. Way to go, Caleb. differentiates with these parts right here and right here. That's going to be the interval that I'm looking for. So as long as we know one standard deviation, we need two standard deviations up to be 95%, and then, or the top 95%, half of that, and then two down go another half of 95%. So what's that standard deviation? Work out? Alright, I got same thing. And I didn't round it for right off the bat, I just kept the whole shebang right there, just because I didn't know what I was really going to need. So what I did was, how do you find out what one standard deviation of is? Add it to 0.44, okay? So 0.44, and add to it 0.016546. Now, what I did was, I kind of used 4444, like, I didn't just use 0.44 because then it skewed it a lot. But it's up to you how you want to do it. I try to make it as accurate as possible, so I used a lot of those 0.4s in there and added to 0.016546. Maybe we should try to stick around 3 decimal places so it's not too skewed at all for our data. So what does it work out to be? 0.46. Is it as accurate as we can be? Is it a 0 after it? So maybe 0.461. Okay. How much is the next standard deviation? Another. What does it work out to be? 775, so maybe 0.478. Sound okay? Okay, so I've got my top part of my interval. The mean should be between here and what's the lower limit that it should be between? So now to get from 0.44, one standard deviation down, take 0.44 and take away one standard deviation. My goal is really to take away 2 standard deviations from this, because I'm looking for that whole bottom interval at the bottom there. Okay, in order to be successful at this, you got to have a calculator out, because you got to be doing this math. That's how you remember it, by sitting there doing it very long with it. Okay, you can do it in your head. This is a lot of carrying now. I don't want to do this in my head anymore. So what is... I could do it in my head. I don't feel like doing it in my head.
You can do this whole thing. This is super easy without writing anything down.
How?
It's kind of just needlessly, you just be sitting there like this for like 2 minutes trying to do the decimals and get the answer.
Right. So you're saying it'd be harder?
Well, I doubt you could do it in like 6 decimal places accurate.
Correct. All right. So what'd you get for one standard deviation down? 427. 427. Is that rounded correctly? Yeah. Okay. How about another standard deviation? 4. I got negative. How are you guys getting any of that? This is 0.444, take away 0.0161 standard deviation down.
So that'd be 427.
427.
0.44 and negative.
No, we're gonna subtract another standard deviation from it.
What is this?
From the 0.427.
From this one, we're going one more standard deviation down. I got 0.407. Is that accurate?
For the second,
Yeah.
I got 0.4113, but I do 6 decimal places.
Okay. 0.411.
Yeah.
Okay. All right. No biggie. So my interval that I can be confident, I can be 95% confident that the mean or the true proportion is going to land in between there. I should be pretty accurate, wouldn't you say? Joe, cut it out. Thank you. I should be pretty accurate that it's in there. Look at how much is left over for there to be taken up by the mean. It's very not likely that it's going to even be in those little tails. How much is up there? How many percent?
2.5.
2.5% up here, 2.5% down here. Of course, I'm pretty confident it's going to be within that interval. Now, the way you have to write it on the AP exam is you have to write, we are confident, or we are 95% confident. You could say I. That's the interval. 0.411 to 0.478. Those were my boundaries over here and here. Captures the true proportion of people who like ice cream. Now, the reason that I'm telling you what to write exactly, literally, word for word, is because a lot of people are going to say, we're 95% confident the mean is in there. The mean's in this interval. Or people are going to say, the mean is between 0.411 or 0.478. Well, no, it doesn't have to be. There's a possibility it could be out here. But you want to say that you're 95% confident that it will capture the true proportion of people who like ice cream within here. Did I lose anybody on that? You already knew how to do that, correct? Okay, so that's easy. Doing 80% is a little bit trickier because you don't have a method anymore, like this one. This one, you knew it was actually 2 standard deviations away. It actually is a little bit less than 2 standard deviations, so we're a little off than what would be accurate for something like this. So my question to you is, what if we change it to 80%? Okay, it becomes a little bit different of a